Okay, I think we're going to go ahead and get started. We've got a few folks still logging in, but I think a vast majority of people are on board. Okay, so let's talk today about our topic, which happens to be an introduction to tag-based advanced ladder in Cscape. Now, for those of you who were with us a few weeks ago, we did do an introduction or a discussion of a lot of the enhancements that are on the way in 2020 in Cscape, and one of which are lots of enhancements for tag-based advanced ladder. So we're going to talk about some of those today, do some good demonstration for you so you can get a better handle on what we're talking about with this introduction. Okay, let's take a look at our outline. We're going to start out by comparing tag-based advanced ladder with what a lot of you are already familiar with, and that's register-based ladder. Again, a good part of the presentation is going to be a demonstration that I'm going to do. Now, I've recorded the demonstration. That's always a safer bet for having less technical difficulties. So I've got a really nice demonstration for you. We're going to cover variable handling, ladder creation, screen creation, and debugging in that demonstration, and that'll be really a bulk of the presentation today. And then at the end, we've got some related topics we're going to talk about, namely structures. And then, as I mentioned a minute ago, just a quick introduction to user-defined function blocks, which we will cover in much more detail in a couple weeks with a dedicated webinar for that topic. All right, let's start by looking side by side at the different styles of logic programming in Cscape. Now, first of all, if you are configuring screens or configuring your hardware, setting up your communications, all of those sort of ancillary functions that are key to the application, those are done the same way regardless of what logic style you choose in Cscape. But you do have some choices in terms of the logic options, starting with advanced ladder, which is the register-based version. That is currently still, it was the original approach and still the most popular. A few years ago, we added advanced ladder with tags. That's tag or variable based. And of course, that's the topic of our webinar today. So we'll talk about that in detail. And then of course, you also have IEC 61131 as a logic option, which is very popular and offers, the most variety in terms of languages. Although, frankly, the ladder that's included with the standardized IEC 61131 isn't quite as flexible as advanced ladder. So those of you who are primarily ladder programmers, you would probably prefer tag-based ladder as opposed to the IEC. But there's a lot of enhancements coming to IEC as well. So for that group, or for those who aren't sure yet what languages you want to use, that'll be something you'll want to evaluate. Okay, let's start, before we dive into tag-based specifically, let's take a look at register-based. So the key with register-based advanced ladder is that it requires that all variables, which we call IO names in Cscape, all variables have to be mapped to a specific memory address. So whenever you add a variable, whether that's a normally open contact, whether that's a actuator or some sort of analog input, all variables have to be mapped to a specific memory address. So you do that with every single variable. And that's really the style of logic that's been available since the very first version of Cscape back in 1998. We've had a lot of enhancements since then, but the style is basically the same. It's still the most widely used version or style of logic programming in Cscape today. We still teach it in our most recent Cscape training courses. Although there are some downsides, it is the most labor intensive when it comes to replicating code because of those addressing requirements. So if you have a section of code that you want to replicate within your logic, because let's say you have multiple pumps that you want to control and the logic is basically the same, you can certainly copy and paste your logic. That's not a problem. But you do have to manually, after pasting, you do have to manually readdress the pasted portion of the code for it to work properly, and that's extra work. And so that's one of the reasons why a tag-based approach, which we'll talk about in a second, is more popular, or at least more flexible in that regard. Also, the register-based advanced ladder for similar reasons of addressing. It does not support user-defined function blocks. And those are very powerful tools that allow you to replicate your logic or portions of your logic and reuse it in multiple sections of your code. It's just a modern approach to that sort of code utilization that, again, is not possible with register-based advanced ladder. Now, when we contrast that with tag-based or variable-based, we use both those terms kind of interchangeably. So we'll say tag-based advanced ladder, sometimes we'll say variable-based advanced ladder. It's the same thing. We use those two terms interchangeably. One of the advantages is that you do not have to map many of the variables or most of the variables to specific memory locations. So that's not an issue. In general, you create your variable names and Cscape in the background will take care of mapping those for you. Now, our tag-based advanced ladder has been available for several years, but we've recently, and I'll talk about that in a second, made some enhancements that should overcome some limitations that may have kind of prevented some folks from jumping on board. Tag-based or variable-based advanced ladder is certainly considered a more modern approach, and we will start teaching our upcoming Cscape training courses later in 2020. Of course, that's all dependent on the whole COVID situation, but we're going to start transitioning to tag-based training later in 2020. That's what we'd prefer to do. And again, like I mentioned a minute ago, there are several new enhancements being released that should promote the use of tag-based advanced ladder for more and more customers. First of all, one of the limitations that we're eliminating, currently, if you're using tag-based ladder, you're limited to about 10,000 registers, which is a lot. But in larger applications, it's just not enough. So starting with Cscape 9.9 Service Pack 3, you'll have access to all the register memory, the ability to effectively assign variables and take advantage of all that memory with the tag-based approach. Also, you'll be able to make online programming changes. So those are changes where you make a download of your code changes to the controller without stopping the controller. So effectively, there's a separate area of memory where the downloads go to, and then with a single swap, the program that's being executed is switched from one scan to the next, and there's a seamless transition from one program to the other without any stopping of the logic. So that's a feature that we're adding into the tag-based advanced ladder with Service Pack 3 as well. Again, user-defined function blocks, a key feature being added in Service Pack 3. And a matter of fact, we're dedicating an entire webinar in 2 weeks to that very topic. And this is a key one for a lot of you who have quite a few existing programs that you're maintaining that you'd like to carry forward. With Service Pack 4, later this summer, you'll actually be able to convert those existing register-based programs over to the tag-based approach. So those will be some key enhancements that we think will make the tag-based advanced ladder more popular. Okay, let's take a look side by side now at a couple of the key differences, starting with memory mapping. And let's take a look at the register-based advanced ladder, which you see there in the diagram in the center. So as I mentioned in the previous slide, all variables must be mapped. So in that center graphic there, you'll see not only shaded in blue, which are the IO names that we assigned to those elements in the logic, but you'll also see for every single element in yellow, mapping of each variable that had to be done by the user. So again, that's an extra step that would not be required in tag-based, which is shown on the right. Most variables do not require mapping. And when you look at the logic, that little snippet of logic there on the right, you'll see strictly variable names highlighted in blue without any references to mapping because it's not required for most variables. But there are some exceptions. So variables that are tied to real world IO do need to be mapped. So if you've got a digital input, say from a limit switch or a actuator like a solenoid, those devices are going to be wired to specific input and output terminals on the OCS or the IO module, and those will require a specific memory address to be mapped to those variables. So there will be mapping required in those cases. Another case which will require mapping is when you're using something like, let's say that you've got a Modbus TCP client, or master as some would call it, that is polling an OCS to grab some data using Modbus TCP protocol. Well, that's a memory mapped protocol, and so therefore there will need to be mapping of those variables that are going to be polled by the Modbus TCP client. Those will have to be mapped as well. And then another scenario would be in the case of indirect data moves, where you're moving data not from point A to point B directly, but you're using pointers from the source to the destination. And so in those scenarios, some mapping will also need to be made. But in general, those are the exceptions. A lion's share of the variables do not require mapping. Now let's take a look at variable creation and maintenance, starting with register-based logic. You can assign your IO names and do your register mapping on the fly if you choose. Every time you add a contact, every time you add a function block and you want to fill in the parameters or the variables, they don't have to be predefined. You can do that on the fly. But as you do that, you have to define at least the memory address, and best practice says you also assign, of course, an IO name so that it's more readable and easier to follow the logic that you're creating. And also in register-based logic, you have the IO names dialog that's used for editing, adding, deleting, copying, pasting. That's a tool that can be used to manage your variables when you're not creating them on the fly. Now let's take a look conversely at tag-based advanced ladder. There's some differences. Now certainly you can still add variables on the fly. So as you add, and you'll see it in the demonstration, as you add variables and fill in function blocks and Boolean elements and those sorts of things, you do have the ability to go ahead and just name the variable right there, but you don't have to map it in most cases because of the fact that Cscape will just handle that for you. And then in terms of how you manage the tools that are there for managing your variables, we don't have the IO names dialog, we have the program variables window. And that is really, that shares the same tool that we use in our IEC-based logic for Cscape. So that's the tool you would use for creating variables ahead of time, or managing the variables, deleting, adding, etc., when you're not creating variables on the fly. Okay, so now we've come to the demonstration portion of our program today. So I'm going to go ahead and start that. And this will really show you, how the tag-based logic works. Again, we're going to show variable handling, we're going to show logic creation, we're going to show screen creation and debugging. So let's go ahead and move to that section of the program. Okay. Let's take a look at how we can use advanced ladder with tags. All right, so I'm going to create a new, I'm in Cscape here. I'm going to go ahead and create a new file or a new program. Okay, when I hit new, I'm presented with the options for the languages I want to use for logic. Between just regular old advanced ladder, this is the one with registers, IEC, and advanced ladder with tags. We're going to go ahead and select this one for this project. Now, some of you may be saying is, wait a minute, when I open up when I create a new program in Cscape, I don't get that option. What's up with that? Well, you need to make sure that under Tools, Application Settings, that Advanced Ladder with Tags is checked as an option. So of these three options here, regular old advanced ladder, IEC, and advanced ladder with tags, for each of these that are checked, those are the options you'll receive when you create a new file. Because remember, that's the time you have to select your editing style for logic when you create the program. So if that's not checked, that bottom check mark is not there, then you won't get that option when you open Cscape. So you want to make sure that's checked. Okay, so let's take a look here. So what I have here is my desktop, set up typically the way I like it. I've got my project navigator over here. I've got my toolbox with all my programming options there. And then down here, I have what's called the program variables table. Now, how do I make sure this appears? And keep in mind, when we're using just regular old advanced ladder, under program IO names is typically where we manage our variables, okay? If we want to go ahead and add or delete or just edit variables alone and not create them on the fly, we do it from the IO names. But you can see here, this is grayed out, so that's not an option with advanced ladder with tags. So you're going to manage those from the program variables table. How do I access that? Well, if you go to the tools area where your navigator and your toolbox are, you can see that the program variables window is available there. So if you click that, if it's not available, if you click that, you'll see it pop up like I've got here. Now, when it pops up, it might be docked over here somewhere. It could be docked at the top, docked at the bottom. You can just pick it up and move it to where you want it to be. Okay, now let's take a look at what we have as the default in the program variable table. First of all, we have two different categories of variables. We have global variables and retained variables. Now, global variables are available really anywhere in the program, as are retained variables. So don't let that kind of fool you by the description. Retained variables strictly are ones that on power up, their value is retained from the last power down, whereas global variables always start out really at 0 effectively. So let's take a look. First of all, there's no retained variables defined yet. And under global variables, what we have here is a list of kind of predefined variables here. And these are predefined variables for things like a real world IO, network global data, system bits and system registers, as well as function key type data. Now, first of all, these are predefined, but they're not really required. And frankly, when I'm doing advanced ladder with tag type programming, I typically get rid of all or most of these. But what these are arrays, arrayed variables. So this is a variable called AI that is an array with a dimension of 512. So it's from 0 to 511. And it's mapped or tagged, it's mapped starting at AI1. So effectively, this is a default array of analog input variables that are mapped from AI1 to AI512. And again, these are here for convenience. I don't find them all that convenient. So one of the first things I often do is delete these. But anyway, as we create variables, either on the fly or, if we do them, from this tool, they're going to show up here, and they'll by default will show up under global variables. If you want them to be retained and you've created them on the fly, for instance, in a dialog box elsewhere, you'll need to move them down to the retained area. All right, now that we've taken a look at program variables, let's just start building logic and see how it compares to when we do it using the kind of old-fashioned register-based approach. Okay, so I'm going to go ahead and just build a simple start-stop circuit. All right, I'm going to go ahead and drop a normally open contact in the first column there, which will create a new rung. And it's going to ask me for the variable or address that I want to assign here. Now, if you remember correctly, in register-based logic, we have to define the register location, and if we choose an IO name to go along with that. Here we just have one choice. Now, we can select a new variable here, or we can just type a new one in. Let's go ahead and do that. I'm going to go ahead and call this start_PB for start push button, okay? And I'll hit OK. Now, Cscape recognizes the fact that this is a variable that does not currently exist, asks if I want to create the variable. I say yes. And then what pops up is this tool here, which is probably unfamiliar to you if you haven't used our tag-based editor before. And this is where you can define things like what's the type of the variable, in this case, Boolean. Is it global, or do you want to put it under the retained section here? Or do you want to create a new user group? Again, you have the ability, if you want, to actually assign or create what's called a user group, so you can kind of group your variables together by category, but that's strictly up to you. It's the only two user groups that are predefined are global and retained. And then if you need to map it to a specific location, then you can do that from here. We'll talk about that in a minute. But for now, this all looks good. It's just a single variable. I'm not going to make it into an array. If I was going to make it into an array, I would change that here. And I'm happy with it the way it is. I'm going to go ahead and hit yes. All right. And as you can see, the start push button variable, which was created, has been automatically added to the global variable section. Okay. And if I needed to move that, I could move that later. But I'm happy with it for now where it is. Okay. So let's continue on this path. I'll go ahead and create a stop push button. Okay, hit OK. Yes, I want to create it. Boolean, everything else by default is fine. I'll say yes. It gets added to my list, as you can see here. I'll go ahead and add a coil now. Let's call this something simple like motor. And again, as I add these, it allows me to create them on the fly. Again, the type is right. Everything looks good there. Okay, I've got motor. And then I need to provide a seal around the start button. All right, and now in this case, motor is already created. So there's a couple things I can do here. I can just start typing it in. And once it finds it, it fills in the rest. And I can say, okay. All right, the other thing I can do is I can press this button right here, which takes me to all the predefined variables that I can choose from. But from now, we'll just go ahead and go with this approach. All right, so now I've completed this. Simple start, stop, run. All right, now let's take a look at a couple different scenarios. Let's take a look at, first of all, let's take a look at this scenario where the stop push button is mapped to a real world digital input. Okay, so let's say that on the OCS, input number 5, physical input number 5, %I5, is the physical input where the stop push button is going to be wired. Okay, so right now, stop push button is just being handled as an internal variable. There's no specific memory address tied to it. Cscape is just assigning something in the background. So if I want this to be tied to the real world input 5, okay, then I'm going to need to map it, or tag it as it's called on this list, with a specific address to make sure that this variable comes from that specific input. Okay, so I'm going to go here under the stop push button variable under my program table, and in the tag column, I'm going to go ahead and type in %I5. Okay, so now what that means is Cscape, or the OCS ultimately, when this is compiled and downloaded to the OCS, will look specifically to input number 5 to that specific address for this specific variable here, which is very important. So even though this is tag-based and it's not, you don't have to assign registers or memory locations for each and every variable, there are certainly scenarios where you do have to assign them in the case of real-world I/O for sure. And then motor seems like another obvious one, which would need to be mapped or tagged to a specific output. So let's say it's output number 3, Q3, which specifically is wired to the motor starter. So under motor here, under the tag column, I'll go ahead and type in %Q3 if that is the specific output that the motor starter is wired to. Okay, so now I have real world inputs tied to motor, or output in this case, but input in the case of the stop push button, and the seal here, of course, which is tied to the motor. But let's say start push button is a touchscreen type push button. All right, how do we handle that? Well, let's go ahead and go to our graphics editor. Okay, and you see it pops up like normal. In my case, I'm configured for one of the new EXL6, I'm sorry, the EXLW's widescreen models. That's our new model we released last month. And I'm going to go ahead and start creating screens. So let's go ahead and put a push button on the screen that we're going to use as a start push button. All right, so let me double click on it here to configure it. I'm going to go ahead and make it round. I'll give it a 3D bezel. Under legend, I'll say start. Okay, we'll bump up the font a little bit here. All right, let's make the push button a little bit more interesting. Let's make the on color bright green and the off color dark green. Okay, so we've defined this push button in every way except what variable it's tied to. Okay, so in this case, we want this to be tied to that start push button variable that we've already created on the fly in ladder. So I can, as I did before, I could just start typing in start PB, or if I don't remember the name, for instance, or I just want to pick it from a list, I can click on this tool right here, or this button right here, and I have a list of all my predefined variables. Now here's all those arrays I talked about before that are kind of predefined that I don't necessarily find all that useful. And then here are the other variables that have been added. So in this case, the start push button variable is what I'm interested in. So I'll just hit OK. I'll double click on it instead. There we go. Start push button is set for a register width of 1 bit. I had previously defined all these things. So there we go. So I'll hit OK. All right, and there we go. So now there's our start push button that's tied to the appropriate variable. Now, it would be useful to know when the motor is actually running. So let's go ahead and put an indicator next to that as well. So I'll just go ahead and select the indicator, object, drop that on the screen, double click in here very quickly under legend. Oops, let's just go ahead and type in motor run, bump the font up a little bit. Okay, on color is green, off color is red. We'll leave that alone for now. We'll give it a 3D bezel. And then under variable, again, I can pick it from the list or I can start typing it in. Now I have to remember that it's motor. So I'll go ahead, yep, there we go. I started typing motor and now it showed. So we're good to go there. Okay, so we've done our extremely simple first screen here with start and motor run as an indicator. Start as a push button, motor run as an indicator. Okay, so now let's go back into our logic editor. Okay, there we are. Now we should have the ability to go ahead and download this to the controller and check it out. Okay, to save time, I've already downloaded this program, so I didn't record that part. So don't forget to download to the controller. I've already done that here and that's complete. Okay, so now my program, which I developed just here a few minutes ago, has been downloaded to the controller, which is in run mode. Okay, and let's go ahead and go into debug mode and check it out. All right, now debug mode is very similar to what we currently, or what you may be currently used to in the register-based logic. So we still have the debug tool. All right, so we'll enable debugging. And as you can see, we have power flow, or the availability of power flow for the stop push button, but nothing else anywhere else. Okay, so let's take a look at the start push button, which we know is touchscreen based. I'll go ahead and touch it here in the controller. You'll probably hear a beep. All right, and as you can see, and now I'll release the push button. Debugging works very much the same as you would expect. Okay, so that's just simple Boolean logic, creating variables on the fly, which we did as we dropped the elements on the screen. Okay, now let's take a look at timers and counters. Now, timers and counters are handled a little differently in tag-based logic than they are in a register-based logic, although it's very, very similar. To review, we know that timers and counters take up two consecutive words. The first word being the accumulator, what the elapsed time is or what the total count currently is. And then the second register, or the second word, is what we call a housekeeping register. So that's one we just need to make sure that we don't step on with the rest of our program. So how would we do that in tag-based logic? Because we really kind of need two variables assigned to that timer or counter. But really the way to do that in the most simple fashion is just to create a variable with a dimension of 2, or an arrayed variable. So down here under program variables, and I'll either put it under the global section or the retain section, depending on whether I want it to retain its value on power down or not. Okay, I'm going to create a timer for the sake of argument. Let's say that I don't want it to retain its value on power up. So under global variables, I'm going to right click and create add variable. I could also use my insert button for that. And what I'm going to go ahead and do is create a new variable. Double click here. I'm going to call it motor timer. Okay. Now, by default, it defines it as Boolean. We're not looking for Boolean. We want an integer here. So I'll double click on this list, and I've got the list of the options here. Now, very important. This is a little bit of an anomaly, but you'll see a complete list of different types that also includes our IEC data types, which list is much more extensive than what you have for advanced ladder. So you need to really ignore all the ones in the bottom there, and the only ones you really care about are here at the top. So what we're looking for is, let's say, an unsigned integer, okay, which is right here on the list. Double click there. All right, and we want this to be an arrayed variable with the dimension of 2. Okay, and that's shown here as 0 to 1. Okay, so motor timer sub 0 is going to be my accumulator, and motor timer sub 1 will be my housekeeping register. And I'm pretty much not going to use the housekeeping register, but at least it's been defined and I won't accidentally step on it. Okay, so I've defined this motor timer variable ahead of time. When we did all this logic up here, we defined everything on the fly. You don't have to do that. You can create your variables ahead of time, and that's what we've done in the case of this timer. Okay, I'm going to go ahead and slide this out of the way a little bit. All right, and let's go ahead and set up the logic for this simple timer. So what we're going to do is we're going to time whenever the motor's running. So I'll create a new rung here. Again, I can pick it from a list or just start typing. Okay, motor. And now I'm going to select timer. All right, so I've done that. Now, the address I'm going to select is this one right here, motor timer. And I have to select sub 0, all right, because it's the, I have to define the first, just like when we're defining register-based logic where we would say R1 or R3 or R5, we have to define or assign the first register, which is the accumulator. We're assigning the accumulator here as well. So I'm going to go ahead in this case and pull it from a list. Go down here and find motor timer sub 0. Okay. Double click on that. Okay. Motor timer sub 0. 100 millisecond resolution is fine. Let's say we're going to count to 5 seconds. Now I can assign a variable here, which I could create on the fly for the preset value. And let's go ahead and do that here. Again, showing you that you can create variables on the fly. Now in this case, I've always just started typing them in and hitting return. In this case, I'm going to go ahead and use this right arrow key. Okay, and I'm going to go ahead and just start typing my variable here. So let's go ahead with, I'll just call it timer preset, and I'll hit the check mark button here. Okay, here's timer preset. It shows an unsigned integer, which is the type I want. If I need to change it, I could do that from this pull down here. If I want this to be retained, okay, I can put this under retained variables here, right from this list. Let's go ahead and do that. All right. This is just not a dimension variable, so I don't want to change this. It's not an array. I don't need to map it or tag it to a specific memory location, so I'll leave that blank. So effectively, we're good to go. So really all I did here was accept the defaults, check the type, and change it to retain. Hit yes, and okay. All right, so now you can see here, I have assigned my timer, and my timer has been assigned, the accumulator has been assigned to motor timer sub 0, and my preset has been assigned to the variable of timer preset. Okay, let's go ahead and add this timer and this preset to the screen that we previously created. So let's go here, back to the screen editor, have that pop up. I'll go ahead and maximize it so we can see it a little better. All right, now I'm going to pick a data object. Okay, there we go. And I'll go ahead and add two data objects. One for the accumulator, the elapsed value of the timer, and I'll do the other one for the preset value. So let's make this one the preset value. Okay, so this is going to be a 16-bit wide variable. We want this to be basically a decimal format. All right. Under variable, let's pick our preset from the list. Timer preset right there. You notice it has a slightly different icon. When it's retentive, it has a little different icon. It looks like a little disc. All right, so I'll select the timer preset, and I'll double click on it in this case. All right, let's say we want this to go as high as, let's say, 99 seconds. Now that's too short. Let's just go ahead and leave it long here. Under engineering units, well, actually though, there's if we're going to display it in seconds, we should put a decimal point in there. So let's just go ahead and pick this guy, 4 digits maximum to the left and 1 digit to the right. Our engineering units, we'll go ahead and make this in terms of seconds. We'll make the font a little bit bigger. Okay, we'll go ahead and center the value. This is a writable parameter, right? And we'll go ahead and allow the preset to be set as high as, let's say 999.9 seconds. And under legends, let's say preset, motor preset. Motor timer preset. I'll make the font a little bit bigger here and hit OK and OK. All right, so we've got our first data object for the preset. And instead of just creating a new one from scratch, let's just copy this one and paste it. All right, and edit it as opposed to strictly creating from scratch. We could do it either way. I'm going to change my variable from timer preset to motor timer sub 0, because remember, that's our accumulator. This is our housekeeping register we're staying away from. Okay, so I'll double click on that. The elapsed time will be in seconds, so that's all good here. That stays the same. However, this is read only, not read write. And our legend needs to say, let's just call it elapsed time. Okay, and okay. All right, so we have added our preset value and our elapsed time. All right, now let's go ahead and download the program. Okay, to save time, I went ahead and downloaded my program offline. Don't forget that step. As you make programming changes and you want to test them, you've got to download to the controller. Okay, so before we can really test this, we need to make sure that there's a value under timer preset. I'm going to go ahead and do that from the screen. Remember, we made that variable editable from the screen. You won't be able to see that, but I'll go ahead and type that in on the touch screen here. You can hear the beeps as I'm typing in the buttons. Let's make it 15 seconds. All right. Now let's go ahead and go into debug mode. Okay. You can see our preset is set to 15 seconds. And we're ready to test it. So I'm going to go ahead and start the motor, and you can see we're timing. Okay, so that's working fine. Okay, so we have covered Boolean logic and we've covered timers and counters. Okay. So that's the demonstration portion of our program. As you can see, it's pretty similar to what many of you may be used to who are doing register-based programming. It's really not all that different. So it's fairly easy to learn. Little differences in the way you define variables, little differences in when you have to map them and not map them. But in general, it's not that bad. So hopefully that demonstration gave you a good flavor for what it looks like. Now, some of the real advantages, besides not having to actually, map a lot of your variables, is there's some extra features included in tag-based advanced ladder that you can really take advantage of. One of which is structures. So what is a structure? Well, a structure is a meaningful group of data that can be used as a complex variable type. And this is just not available at all in register-based logic. So let's take a look at that center graphic there inside the red box. So what I've done there is I'm showing the creation of a structure called motor underscore control that has 6 different elements in it. Okay, and they're a meaningful group of data. That's what makes them a structure. So you've got 6 different elements, 3 of which are Boolean, start, stop, and fault. We've got a couple of unsigned integers, restart time and RPM, and then you've got a real value in amps. So again, those are all different elements that are all related, but many of them have different data types, and you can group them together there as a structure. Now, after you create a structure, and this one, of course, we created, it's called motor underscore control, then you can use that as a type as you create new variables. So if you look above the red box, highlighted in yellow, you'll see we created a new variable called main underscore motor, and we assigned a type of motor control to that. So now main underscore motor variable has all those different elements to it because it's been assigned the type of motor underscore control. And that is reflected on the right there as we take a look at a snippet of ladder logic. If we take a look at that first rung, you'll see 3 highlighted in yellow elements, main underscore motor dot start, main underscore motor dot stop, and main underscore motor dot fault. So those are the first 3 elements there, the Boolean ones that we're using in that first rung of logic. In that center logic, you'll see we're doing a calculation there, and we're calculating main underscore motor dot amps. That's the real element to that structure, which is handled there or shown there in that middle rung. And then the bottom rung is showing one of the unsigned integers that is assigned to that structure and part of that variable, which is main underscore motor dot restart time. So as you can see there, what you have is the name of the variable is at the beginning when you're, putting the nomenclature on the element, and then followed by a dot, and then the element name. So main underscore motor .start, for instance. So again, that can be really useful. You can reuse those structures over and over again, and they can be used with regular variables. They can also be used with arrayed variables. So you can take that to the next step, where you have not just a regular variable with a dimension of 1, a single dimensional array, but you can use it with an arrayed variable. So as you can see there, we created the variable motor, which is an arrayed variable with up to 8, motor sub 0 through motor sub 7. That follows that structure of motor control. And then you can see on the right, the nomenclature is very similar as you assign the variable, but now you have motor sub 3 .start, motor sub 3 .stop, for instance. So again, structures are very useful features, and they're useful not only as with regular old variables, but also with arrayed variables. And then really another power feature when you're talking tag-based ladder are user-defined function blocks. So what is a user-defined function block? But it's a ladder routine that can be modularized as a function block where you assign inputs to the block, outputs from the block, and local variables used within the block. It allows your code to be efficiently replicated. So you could be doing an application that's doing pump control, for instance, and you could have defined ladder logic for controlling a pump. And as you add multiple pumps that are controlled in the same way, you can create a pump control user-defined function block and use that for multiple pumps very efficiently. Also, these can be OEM protected, which means that you could, if you chose, create a UDFB that can be used as a black box by your customer, if you will, but the customer would not necessarily see the secret sauce within the black box because it's OEM protected. So that can be a useful feature for OEMs that want their users to be able to access the logic for debugging and troubleshooting purposes, but you don't want to expose your secret sauce to your customer. And support for UDFBs has not been available until 9.9 Service Pack 3, which we anticipate will be released later this month. And again, this was a quick introduction to UDFBs. We're going to cover them in great detail 2 weeks from today in the May 27th webinar. Okay, so let's go ahead and I believe we're ready for the question and answer session here. So let's start diving through what questions we have. So the first questions I see here is, when will Service Pack 3 be released, and how about Service Pack 4? I'm currently working with the second beta of Service Pack 3, and it seems to be pretty solid. I would guess that we're within a week or two of getting Service Pack 3 released to the field. Based on what I'm seeing today, it's looking pretty good. So that one's relatively imminent, I would say. Service Pack 4 will probably follow in a couple of months. That's the big advantages or the big improvements there that we covered in a previous webinar, include the ability to convert existing register-based programs over to tag-based, and then a bunch of IEC enhancements as well, but we didn't cover IEC today. Okay, is the tagging fully tested and proven or in beta? Now, as I mentioned, that's a good question. As I mentioned, we have supported tagging for some time. So if you want to try out tagging, you can do it with the current version of Cscape, which is Service Pack 2 of 9.9. As a matter of fact, even if you have an older version of Cscape, not, that may be a couple of years old, you can try it out there as well. The only things that you can't utilize with your current version of Cscape prior to Service Pack 3 is you're going to be limited to 10,000 variables, which frankly isn't much of a limitation for many of you. You're not going to have support for user-defined function blocks, but just to try it out, you'll be fine. And that's really just about the only limitation. So feel free to try it out. It's been solid. It's been solid for some time. It's just some of the limitations and the lack of UDFB support and the lack of the ability to convert old programs to new programs have been some of the limitations that have prevented people from taking the leap. But hey, by all means, try it out with your current version of Cscape. Why not just have predefined timer and counter registers? Good point. That's certainly an approach we could have taken. but we didn't have that approach with our register-based logic. A lot of PLC manufacturers have, since the beginning, back when they were strictly register-based as well, they had defined specific types for timers and counters, which the disadvantage to that is you're kind of limiting how many timers and counters you can have. So what we've always done, for better or for worse, is said, hey, here's all of our registers you've got available to you. If you want to use a timer or a counter, it takes up 2 of them, and knock yourself out, use as many as you'd like. Whereas a PLC manufacturer that says, hey, here's 1,000 or 500 or 50 or 20, whatever the number may be, that's how many timers and counters you can have. That's what you're limited to. So you're right, we could have taken a different approach. We didn't. That's a valid point. Okay. From an OCS performance perspective, is there any performance benefits between variable-based or register-based files? In general, no, not really. There may be cases where it's not quite as efficient, but in general, you're not really taking a significant performance hit to go with a tag-based approach. Now, this I will say, for those of you who are looking at IEC, the current version of IEC, the one that we've been selling for the last several years, that one that won't be updated until Service Pack 4, there is a significant performance hit for IEC. Today, that'll be taken care of with Service Pack 4, but today there is a I guess a less efficient means that we're using to effectively take the logic that's developed in IEC and execute it at runtime. With our current IEC approach, you do have a performance hit there, but we're going to get rid of that with Service Pack 4. But from a tag-based standpoint, there's not a lot of issues there. And then the next question is, can you nest structures? I don't think so, but I will follow up on that question. Nest structures and see if that might be possible or not. I don't think so, though. What firmware version will be required to use these new features? For my purposes, I'm using an XL7. Okay, so once again, if you just want to try out tag-based with your current version of Cscape, your current version of firmware will be fine. So just to try it out, there's no issues there. Now, when we introduce Service Pack 3, that Cscape version, now you're talking about support for online programming, support for user-defined function blocks, ability to support up to 50,000 registers internally mapped by Cscape, all those sort of enhancements. That's going to require some new firmware. I believe it's going to be somewhere on the neighborhood of like 15.38 or somewhere like that. So something in that area is what you're going to see. I think the current version for most controllers is around 15.3. So it's going to be somewhere in the 15.35, 15.38 area. But we'll announce that as we announce Service Pack 3. Let's see, again, another question about the release date for Service Pack 3. It's trending for some time in the next couple of weeks. Again, I'm working with the second beta, and it seems to be pretty solid. Let's see, is there an application note for structures? I don't think we have one. I'll go take a look at that. That's another good follow-up call we can take a note on. Certainly what we will be doing, though, as a follow-up to that question, we will be posting that demonstration. We're going to be taking that demonstration video I just showed you and slicing and dicing it a little bit and posting it on our website so you can access it later, you know, if you want to review timer and counter operation or whatever the case may be that we covered in that video. And then we're also going to be doing a short video on structures as well. So, you know, in lieu maybe of a white paper, if we don't have that already, you certainly are going to see very soon a video specific, probably about a 4 or 5 minute video specifically geared on creating a structure. So we will definitely have that. I've got that planned to get that executed quickly. Let's see, if you wanted to access a variable externally with Modbus TCP, would you assign a register location as a tag as per normal? So effectively what you would do in that scenario is, if you remember in our demonstration, we tagged or mapped, really. We mapped, I think it was, you know, %I5 to the stop push button. So it would be a similar approach if you're using Modbus. So with Modbus, you have a standardized memory map between Horner style %R registers, for instance, and Modbus style holding registers. So you effectively would take you would take all the variables that you wanted to be made available over Modbus, and you would map them into %R memory locations, which had a known corresponding Modbus map. And the Modbus to Horner memory map is widely available in all the users manuals for well, if it's not in every user's manual, it's certainly in the Ethernet supplement, which is widely available on the website. So again, it's just a matter, in that case, of taking the variables individually that you want to map over to Modbus and assigning each one of them the appropriate %R register, and you can effectively then create your own Modbus map within your program. Okay, conversion tools will follow Service Pack 3, correct? Absolutely. Service Pack 4, the big feature there from a tag-based standpoint, is the ability to effectively open or import a register-based program that maybe you've been using for years, save a copy of it as a variable-based or tag-based program, and effectively we, at that stage, will take all your IO names that you'd previously created, turn them into variable names. Anything that you didn't name, maybe you might have some just memory locations, M5, R7, that didn't get named, through sloppiness or just, incompleteness, we'll assign names to those that are as of yet unnamed and do the conversion. So yeah, that'll be available with Service Pack 4. Can you show assigning the actual IO to a structure? Example, motor3.start. So how we do that? That will be covered in our video that I'll follow up with. I don't know if I'll tell you what, at the end of this question, if I still have that program pulled up on my Cscape, I'll try and demonstrate that at the end. So let me see if I can do that at the end, if I still have my Cscape program available here. Screen push button and physical push button tagging. Yeah, so effectively, you generally, for screen push buttons, they don't need to be mapped. Okay, so you create a variable name, and you don't have to map them to a specific location or tag them, as some people would say. They don't have to be. They're just internal variables. So you don't have to assign a T-bit or an M-bit or any of those sorts of things to it. Physical I/O, absolutely you do, because it's wired to a specific location, either input or output. So we talked about that, and absolutely you need to map/tag any variable which is connected to real-world I/O. Okay, let's see. Will you send out the recording link? Absolutely. Cole's going to post this tomorrow or today, maybe even, but certainly by sometime tomorrow. So that will be. And keep in mind, our videos are all available in the video section of our website. Now, how can you find the video section of our website? You go to hornerautomation.com, and there's a resources tab or resources area, and one of the choices under resources is videos. So click on that. At the top of that page, you're going to see quite prominently the WebMI how-to series of 7 videos that we just posted there last week. And also, you'll find past webinars we've done, and that's where this particular webinar will be posted as well.
Also, the most recent, like the April and May webinars, they're going to be on the webinar webpage as well, which can be also found on the resources tab.
Okay, very good.
So multiple places.
Well, okay, so let's see. We've got some questions regarding WebMI. How does this affect WebMI? I think I'll follow up with that one. I don't think it has a big effect on WebMI. I think when you go to assign your variables, because really WebMI development is just like screen development. So effectively, as I showed you how you assigned variables to screen objects like that push button and the data objects, you would follow the same approach for WebMI. I don't believe there's anything else that I need to extrapolate on that. But if there is, we'll follow up on that. Are we planning to launch a Cscape version for Mac? So currently, no. We're not. I currently have a Mac, as many people do, and I use a VMware, a virtual operating system. That's my case, it's Windows 7, but I also have Windows 10. And I actually have a lot of colleagues that are system integrators, for instance, that like the virtual operating systems, or the virtual machines, I should say, because it allows them to have multiple virtual machines on the same computer. So lots of times, like if I'm a system integrator and I have to work on Horner equipment and Rockwell equipment and Siemens equipment, Horner plays pretty well with the other guys, but the other guys don't always play well with each other. So having a dedicated Siemens machine or Allen Bradley machine can be an advantage in those cases. So we haven't had a real big incentive to develop Cscape for Mac because the virtual, the VMwares and Parallels of this world running copies of Windows works really well. And I've been using it for many years now, and I can attest to that firsthand. Let's see. Okay, so how do I access the timer running bits in the second register? So yeah, so that's not as easy to access with the tag based as it is in the register based approach. But you can, but I can go ahead. That's one we'll follow up on, Cole. I think I can show an example of how to do that. Let's see. Are there going to be predefined structures for timers, for example? We very well may do that. We could ship Cscape so that when you open it up, you saw those predefined arrays that we had put in there that show up at the beginning that you can just get rid of if you don't like them. The ones for the AIs and Is and Qs and IGs and all those. We very well could predefine a timer structure. That's something we could decide to do, but I'm not sure if we are going to be doing that or not, but that's something we could decide to do. Let's see, asking about any special function for rebooting a controller. We don't currently have a system bit or system register for rebooting an OCS today, regardless of what language you're using. That's something we're looking at in the future, especially when it comes to like resetting like resetting like Ethernet stacks and those sorts of things. Sometimes with Ethernet, especially for things like FTP and email, we're playing with other devices that don't always play right, and sometimes we don't play right either. I'm not going to say we never have issues, but if you have a FTP client, for instance, that screws up and opens up too many connections and doesn't close them and those sorts of things, which is always possible, sometimes it's handy to be able to do things like reset the Ethernet stack. So we're definitely looking at some system bits to be able to do those sorts of functions in the future, but they don't exist today. Let's see, bit addressing for timers. That's something I should follow up with there. Will there be a tag-based program for updating any kind of demo hardware? Certainly, we can do that. For those of you who are channel partners who have Horner demos out there and would like to get programs to be able to do that. Let's see, structures and arrays will facilitate function block development. How easy is it going to be to perform debug? Okay, so what he's asking about is when you are debugging a user-defined function block, how is that gonna, if you've got effectively quite a few rungs of logic that are buried within a UDFB, how's debugging going to go? Well, effectively the way debugging is going to go, and we'll cover that in detail in a couple weeks, but effectively how that's going to go is you're going to have visibility of a UDFB like any other function block. So the code within the UDFB, I believe you're going to have to debug that ahead of time and get that all squared away and solid before you make it a UDFB. Once it's a UDFB and it's its own function block, I believe at that point, it just looks like any other function block with inputs and outputs and those sorts of things. So that's my understanding. But again, I'll cover that in a lot of detail in a couple weeks. Converting a register-based program to a tag-based one will be something that's built into Service Pack 4. And will you be able to debug different instances of function blocks? Yes, absolutely. The user-defined function blocks. Will register-based program be supported for the foreseeable future? So that's a good question. we've definitely debated that. Right now, we're leaning towards yes, continuing to support it beyond Cscape 10, but there are some negatives. One negative is that it's a third language that we have to support. So, you know, we have a limited number of resources for enhancing Cscape, and we want to continue to make Cscape free, which we've committed to doing. But that means committing resources to working on features that people are going to be using. And we get a lot of people that complain that, you know, register-based Cscape, it's old-fashioned, you don't do UDFBs, and I have to assign all these registers, and that's perfectly valid criticism. So at some point, we would like our users, we'd like to make it easy for our users to convert over to tag-based. So that's what we're trying to do. We're trying to make that as easy as possible by converting as many of their programs over as possible, and to make whatever advantages register-based may have, make those kind of disappear. So with Service Pack 3 and Service Pack 4, whatever kinks may be in the works, we'll get those worked out. And it's very possible that register-based logic could go away at some point. It probably will. Let's see. Any upgrades to the Modbus protocol driver to allow more than 30 registers in a request? That's something that's overdue, something we need to do for sure. You won't see that before Cscape 10. You won't see that in the first version of Cscape 10 because it's not high enough on the list. But you're right, we do need to bump that up to make it more efficient. I agree with that. On a high level, how does a UDFB vary from a subroutine? I think I'll cover that in our webinar in a couple weeks. Sorry to kind of duck out of that one. How's your conversion tool going to handle existing indirect moves? Okay, so the way that will work is effectively there are in almost all OCSs that are modern at all, there are 50,000 %R registers, for instance, and 16,000 T's and 16,000 M's. So what we'll likely do is we'll have an upper area that's not used very often. We'll have an upper area of R, M, or T memory, depending on if you're moving, if you're moving bits or words or double words or whatever the case may be. We'll have an upper area of memory address that will be assigned for indirect moves that you'll have the ability to adjust. So you'll be able to check those as you do a conversion and make sure that what's the addresses that Cscape has chosen to automatically map for indirect moves is going to work for your application. So yeah, that'll be a semi-automatic conversion when it comes to indirect moves. We'll select a likely, perfectly fine memory map, and then you'll have the ability to override it if it's not perfectly fine. Let's see, can you import tag names to a new program? Yes, you can. There's 3 different ways. You can use CSV, you can use XML, and you can use like an ASCII text approach. So that's something we'll cover in a future video, but yes, you can do it. It's not exactly the same as copy paste like you do in the IO names, copy paste to Excel, but it is possible, and I need to cover that in a video. Parallels works great as a VM. Thank you for that. I agree. I've used VMware, but Parallels also works really well. That's what my college-age daughters use with good success. Any hope for edge transition contacts rather than coils? I think at some point we'll probably add those, but it's not going to happen in the next, in the next year probably with all the stuff we have on our plate currently. Is it possible to get Service Pack 3 as a beta? That depends. Probably. If we're a week away from releasing it, I'd rather not. But if it looks like it could be a couple weeks, then contact me via email and I'll see about getting you a beta. Okay. Thanks for a great list of questions. There's a lot of things that we'll cover 2 weeks from now that are related to user-defined function blocks. A lot of questions on those, which I expected, so that's good. We also have some followed up, the nested structures and others that Cole will help me with, and some other things that we'll just do some videos to answer in terms of structures and those sorts of things. So thanks again for great attendance and great questions, and I look forward to those of you who can make it next week, same time, for MQTT push protocol, which I think several of you will be interested in, and 2 weeks from now for the UDFB webinar. Take care.